Welcome all. Thank you for attending my talk, and I'd like to thank my hosts for letting me speak here. My name is Carl Anderson. I'm a senior software engineer at Microsoft in Madison, Wisconsin. I work closely with Gino Canessa and Josh Mandel to help develop new FHIR standards and to contribute to documentation and to the open source tools that enable developers to build FHIR-enabled software. I should warn you that I'm new to the standards community, and I've only been with Microsoft for 4 months, so I still have a bit of that new Microsoft engineer smell. They promised me eventually it goes away, but I guess we'll see. And I have to confess that this is my first time in Europe, so please don't hold that against me. I hope it's not my last. Okay, so I'm going to jump right in. To start, let's have a refresher on SMART. And we just had a great primer from Josh. Smart apps are designed to be launched and inherit context from the EHR. So this typically means that the current patient and the current provider, also possibly the currently proposed order, are available to the app that's launched. With SMART plus OAuth OpenID Connect, an auth can avoid a cumbersome login process and enable a very nice, easy entry and smart user experience. The problem with SMART is that the communication path is a bit one-sided. In other words, the SMART app has no easy way to communicate back to the EHR that launched it. Smart web messaging was designed to address that need and to enable bidirectional communication. With smart web messaging, an app can read and modify ephemeral EHR state, suggest further navigation or actions, and say, it's okay to close me now, I'm done. Smart web messaging is simple, and it's based on HTML5 standards, so it should have a relatively easy adoption path in most EHR systems. So now that I've jumped right in, I'm going to jump right back out. Before I get into the technical details of the spec and the technology itself, I'd like to illustrate one of the major use cases where smart web messaging has a chance to really shine in the EHR order entry workflow. The software should not get in my way when I'm trying to practice medicine, Josh Mandel. Now, this quote from Josh really captures the ideal of what we're all trying to deliver as developers. It's a great quote. In fact, when Josh and I were first brainstorming about this session, talking about what we wanted to accomplish in it, he said something very similar to this, which I just assumed was a quote from someone else. And when I asked him about it later, what exactly it was he said and who he was quoting, he said it was all him, baby. So I asked him if he remembered exactly what it was and if I could use the quote in my slides, which led to this quote from Josh. Carl, you can make up almost any quote you want and attribute it to me. And he still hasn't taken that privilege back. But seriously, I took the gist of that first Josh quote to heart when preparing this deck. My goal in this presentation is to illustrate a real problem that's being solved and to help motivate you to explore this technology if you haven't already. And incidentally, we'll get a chance to look at the nuts and bolts of an example. So I'll start with a simple commonplace scenario of a clinician ordering a diagnostic image for a patient. Dr. Brown, the brownish dot in the hospital box, wants to order an image for Ray, the greenish dot. At their initial visit, Dr. Brown selects an order, signs it, and sends Ray to the radiology department of the hospital system. Ray reports to radiology, is seen by a radiologist who performs the ordered scan. The resulting scanned images are provided to the ordering physician via the EHR, or possibly CDs. What you don't see here is that the ordered study was actually of very low clinical value. And later, when Ray and Dr. Brown meet again, they realize that another image must be ordered to provide the additional missing context. So you can see that Ray has been getting slightly greener and greener as time progresses. There's also an indication that money is being wasted and Ray is being exposed to additional radiation and losing time. So what's wrong with this system? Well, there's a big disconnect here. The radiologist and the ordering physician are two totally different people. They have two totally separate sets of goals, and they're communicating through this EHR. They may not work in the same building. They may never actually meet in person. This setup makes it very difficult to share context about a patient and why a particular order may have been signed in the first place. And all this leads to easy mistakes, which can be quite costly in terms of time, money, patient safety. So we have to ask ourselves, is this appropriate use of technology? And what does that even mean? So before I address what appropriate means, let's quickly look at how we got here. Starting in the 1990s, medical imaging devices became more and more available to medical practitioners. But this technology is a moving target. New scanner technologies are constantly evolving, and the best practices keep changing for the new and the old technology. As a practitioner, it was and still is very hard to stay current with best practices. The question for the US government was, what can be done to make this better? And the answer was PAMA, which attempts to be a data-driven solution to the problem of wasteful spending on diagnostic medical imaging. If we in the United States could lower the prices and per capita volumes of our CT scans, MRIs, and just the top 25 high-volume, high-priced surgical procedures to those of the Netherlands, for example, we would see savings of about 425 per capita, or a total of $137 billion. That's a lot of waste. PAMA was signed into law on April 1st, 2014, and it goes into effect in just a couple weeks on January 1st. So here's the current timeline. The program starts on the 1st of next year, and throughout the year it operates in training mode. I'll get into what that means in a minute, but the gist of this is that for the year of 2020, there are no major consequences for providers doing absolutely nothing differently. Then in 2021, the penalties kick in. This is when radiologists will start losing reimbursement for low-value diagnostic imaging, orders that are placed by other providers. So put another way, in this scenario, Dr. Brown's mistake might cause the radiologist to not be reimbursed for that first scan. And at face value, this seems to make the situation even worse. Dr. Brown is already far removed from the radiologist, so that lost time and revenue might mean very little to Dr. Brown. PAMA's answer to that scenario is in 2022, all ordering providers who frequently order low-value diagnostic images may face mandatory prior authorization for placing Medicare image orders. So in the game of sticks and carrots, is mandatory prior authorization a big enough stick? This doctor was so frustrated, he recorded one of his calls to an insurance company where he wanted prior authorization for a pretty obviously appropriate imaging order. Spoiler alert, after 20 minutes, he was told they would fax him some paperwork for him to fill out and then fax back. Now, this should illustrate how doctors feel about wasting their time. You should know your users, and these are our users. So I think I've mostly framed the problem. Let's quickly recap what we know. Our users are impatient, and our solution must stay out of their way while they're trying to practice medicine. Our users can't possibly keep up with all the latest best practices, so the solution has to bring the cutting edge of best practices to their immediate attention when it's relevant. There's a lot on the line in the hospital setting, and getting it wrong can cost people dearly. And finally, PAMA is happening, and it's imposing new requirements for Medicare patients. So the solution has to satisfy those. Here are the broad strokes of how PAMA is designed. There are appropriate use criteria, often just called AUC. They're developed out in the open by experts and researchers, also known as provider-led entities. There's maybe 20 PLEs, each publishing a specialized set of AUC. So there may be like a group of radiologists who publish radiology AUC, and separate groups publish their own AUC. So the software vendors who incorporate this AUC criteria into their software's logic and flow, they first must be vetted by CMS, who runs Medicare, to become a QCDSM, or a qualified CDS mechanism. Once that happens, they're issued a unique publicly available ID, which is inserted into the evidence of guideline consultation that goes into the signed orders. So with this, a radiologist who sees an incoming image order that's missing that evidence of guideline consultation can push back on the ordering provider. So this can create some conversations in these departments, and that's the purpose of having a whole year as a training period before the penalties kick in. So in order for PAMA to have legally taken effect, there must be at least one free of charge QCDSM option, which is available to all doctors. And in fact, I think there's 3 or more right now. And here's what one of them looks like when integrated into our scenario from before with Dr. Brown. Now, keep in mind, this is without CDS hooks, without smart web messaging. The clinician is just using 2 separate browser windows, the EHR and a web browser side by side, and they don't communicate at all. So the first thing is they have to log into their QCDSM. So that is cognitive overhead. They've got to remember their username and password, and then once they get in, they're asked to enter demographic information. And I'm sorry, you can't really see, but that's asking for patient age and gender. So they might have to look back and forth, like how old are they exactly? And then once they've entered that, they're given a list of the available diagnoses. And so they enter the diagnosis they put into the EHR just a few seconds ago, et cetera. And then that takes them to a screen where they can pick an imaging study, and it shows them how appropriate they are. Once they've done this, they're given a numeric code, which they can copy into their clipboard, go back into the EHR, and paste somewhere to provide evidence that they have done their job. And that way, that'll satisfy the radiologist when they see the image come in with a little numeric code in there. So the scenario is even worse when the clinician realizes, using this guideline app, that they accidentally entered a low-value image order. They have to remove that from the EHR and then remember which one they selected in the external app. So remember who our users are. Okay, so I've talked a lot about what's wrong with this scenario, but I haven't really talked about what's right with it. The EHR was already doing a great job staying out of Dr. Brown's way and letting her practice medicine. Dr. Brown was able to efficiently do the wrong thing. It's true that if she had been up to date on best practices, she would have been able to efficiently do the right thing. All that's really missing is an easily automated check in the EHR to warn Dr. Brown that best practices are not being met. And to make a one-click suggestion that will modify the pending order to be within guidelines. And this is where CDS hooks comes to the rescue, and it works brilliantly. So what if this had popped up in Dr. Brown's order entry screen before she signed it? She probably would have at least noticed it. She may have been confused, possibly annoyed. After the 3rd time seeing this, she will definitely be annoyed. Ultimately, she might arrive at the reason in her mind why her order didn't meet guidelines and fix it and avoid sending Ray to radiology more than once. So overall, it's a win for the system, but the user pays for it in lost time, lost satisfaction, confusion, etc. And this is one thing we can get with CDS hooks. We can get this. Now, caveat, I'm not showing a card that has system actions built into it, which might improve the situation, but in certain situations, there might be 100 different options, and you wouldn't want to have 100 different system actions all displayed on the card. So smart web messaging will help with that. So now what if Dr. Brown had seen this in her order entry screen instead? What if she knew that she could click on the blue link, open an app, and that app was embedded in her EHR. It knew who she was. She didn't have to log in. It knew who her currently selected patient was. It knew what she had in the order entry screen already. Now, what if that app could explain to her why the order that she had entered is not within guidelines, allowing her to select it anyway? I mean, she can override it. Within the rules of PAMA, she just has to consult the guidelines. What if anything she did in the embedded app automatically updated her EHR and in the process inserted that evidence of guideline consultation for her? This is the experience that our users want and will soon come to expect. Finally. Now, I'd like to see a show of hands in the audience. How many people already knew all that? I mean, I expect the number to be relatively low since we're not in the US. But it's great if you did already know all that stuff. I've been wrapping my head around it for the past couple months, and I think I still have a ways to go to fully plumb the depths of this situation. I'd like to see one more show of hands. Who here didn't know all that stuff? So we're learning. But keep your hand up if you were bored anyway. And you won't hurt my feelings. And I'm sorry, I've given you 15 minutes of context, which I know is a lot. This is the first time I've given this talk, and I'm thinking about changes for it the next time I'm ready, so thanks for the feedback. And feel free to find me later, and I don't bite. So moving along, I promised that I would show you some of the nuts and bolts of a solution that uses smart web messaging, and I will. To get there, I'm going to start with a toy example app that I wrote. And please don't judge me for my JavaScript and HTML coding abilities. I'm just learning all this stuff too. I'll show you the simple app in a non-smart state. I'll show you how I made it into a smart launch capable system. I'll show you how I connected it to the CDS hook sandbox and demonstrate the CDS hook's action there. And finally, I'll show you how I incorporated smart web messaging in the app, enabling bidirectional communication between the app and the EHR. Okay, so in this slide, I've captured a few screenshots of the app components. It's really simple. There's a fake login, username, password. It just accepts anything. But my goal was to sort of mimic what I saw in the demo QCDSM. This app allows you to select, gender, age, diagnosis, and a procedure, and then evaluate it for appropriateness by some very simple rules. I don't expect you to see and read all this, but the gist of this is it's just HTML. The form is just HTML. There's a separate server process that evaluates the result of the post, and it returns either appropriate, not appropriate, or no guidelines apply. This is code that was sort of lifted from the CDS hook sandbox. Okay, so I used Node and Express to implement the server-side logic. So for many of you, this will be a familiar approach. And we talked about the PAMA logic. Okay, and I put this into a code repository. It's tagged at v1, so if you wanted to check it out and fix my JavaScript, that'd be fine. I designed this with 3 different versions in mind. So version 1 is just the plain non-smart app. For version 2, the main theme is turning it into a smart launch capable app. So we can take advantage of the currently selected patient and provider in the EHR. That alone won't give us the scratch pad, the ephemeral data. But then we'll use that smart launch context to populate the age and gender form fields automatically in the app. Otherwise, though, the app behaves exactly the same way. You click on submit, and it posts to the server, and it gives you the appropriateness. So I should spend a few minutes talking about this tool, although Josh did a good job demoing this at the last talk if you were there. But this is the smart app launcher. This is what it looks like when you go to launch.smarthealthit.org. The important parts for this demo are the launch type, the patient, the provider, and the app launch URL. There, and there. For right now, we could ignore the patient and provider fields, but it's important to know they're there. We'll start by creating a new launch endpoint for our HTTP server. So the launch endpoint is just something that the app launcher reaches out to, and that initiates the smart launch. In order to make the launcher work, there's a JavaScript Fire client, which makes smart launches easy to code. It's also easy to install and configure. It's npm install Fire client. I used this library when I created launch.html, which is simply this. Not that much. So this is where we make the first of 2 important API calls, fire.oauth2.authorize. I guess it's worth mentioning that the scope attribute appears here. Josh talked about OAuth 2 scopes, and they're required for this this app launch, you can see there's a launch item that allows the smart launch to happen. There's OpenID and profile that gives you access to the user, and then patient for the patient information. Okay, so once you have the configuration set and this endpoint running, you can go back to the Smart App Launcher and launch the app. What'll happen is you'll see it launch in, this is optional, you can have it launch within a fake EHR. If you haven't selected a provider in the configuration page, you'll get a picker where you can pick whichever one you want, or you can optionally bypass this by selecting one in the config. Same thing with patient. I found it was handy to not select them because I could select a patient that was a different gender than the default, and then I could confirm that the right age and gender were populated in my form when it popped up. But this is what happens. It populates the gender and the age, but otherwise the app is the exact same thing. And I won't show you all the code that makes that happen because it's just basic DOM manipulation. Okay. So now we have to make our dumb HTML a little smarter, just smart enough to complete the second of two important API calls. Sorry, I'm reading here. I sort of glossed over these when I practiced. You can see that there's a get context function at the top that gets the patient and user asynchronously. So the important part here is the fire.oauth2 ready. This is the second of the two important function calls for the smart launch. That returns a promise, which when you resolve it, gives you the Fire client, which is passed into that function there. The client.patientRead and client.userRead are also asynchronous, so it takes a couple seconds for this to actually load, but this is how we send the context data to the receiving app. So this is still one directional communication. Okay, so it's time to bring this home. Now that we have a smart app, we need to be able to put it in front of users within the EHR. For this, we need CDS hooks so we can get to them while they're in the middle of their order entry. Our objective is to put a card in front of the user when they are selecting their order items. The cards should add value, they should enable smoother workflows, better automation, and they should save the provider's time. Finally, the app must enable bidirectional communication so that changes they make in the app update the EHR. So this is the spiffy new app interface. There are two new buttons and a new text area. Also, what was once the submit button is now the evaluate button. In the earlier versions, the submit button posted to a remote service. Now it will evaluate the form data and display the rating in the text. And that eliminates the need for having a separate service. The red button acts like a cancel. It closes the app and returns you to the EHR. The green button will actually write back into the EHR using the values that you've populated in the form, and it'll finally close the app. These are the new cards that we will deliver to the users in the app. Whenever the user selects an image with an image and diagnosis combination that's appropriate, they get a big green seal of approval. And this is just for easy demo. I mean, you might not want to actually do this in production, but there's an argument to be made that maybe you would. And then when they select a poor image diagnosis combination, they get a big red warning. Everything else gets a question mark. And again, that part was especially for easy demoing. But I sort of thought about it, like it might be a good indication that your hook is working, just to have that there. Anyway, so to create and deliver the cards, we need a new CDS hook service. There's a really good tool to help us with that. This is the CDS hook Sandbox. It's free, open source, and supported by volunteers at Cerner, Microsoft, Epic, and others. This is what it looks like when you launch it. The Sandbox simulates an order entry situation, generating the same UI hooks that the EHRs would generate. Also, it allows you to connect your locally running services to it as you develop. And that's what we're aiming to see. So after writing the demo app, I've tried to separate the relevant learnings from the Carl doesn't know JavaScript ones. I've also tried to address the CDS hooks work in this talk before addressing the app changes, even though when I developed this, there was a lot of back and forth. All told, there were less than 100 lines of code in the entire CDS hook service. So the first part of a CDS hook service is a discovery endpoint. The EHR actually requires to have a discovery endpoint so it can know who's listening to what in the UI, essentially. And in our hook, we care about order select actions. And so this is an order select hook. And we want updates sent to our endpoint at demo AUC app. That's the ID. And in this code snippet, I've taken some liberties in cutting out bits of code, but I think I've kept the important parts. It should give you a quick idea of the goal of this function anyways. This is the actual hook that returns cards. It also serializes the draft order, stuffing it into the app context variable, which is part of card.link.appContext. And this is how I'm sending data from the EHR to the app. When the app wants to update the EHR, it can change that object and send it back using a window.postMessage JavaScript call, and we'll see that too. So that should be enough to get a working CDS hook. Let's take a look at the changes in the app. The app was dumb, then it got smart. Now it needs to start talking back to the EHR. This reminds me of my kids. I added about 100 lines of JavaScript between V2 and V3 to make all this work. And a lot of that is me being new to JavaScript. So there may be a simpler way to do this, but I'll show you the tricky parts. So this library should look familiar. We saw it in the launch.html code. However, here we need to call OAuth2.ready. There we called authorize. I guess we saw this in the smart launch screens. Anyways, calling ready returns a promise, which resolves to an instance of the Fire client. I said that before, but it's worth repeating. This is where we'll find the serialized app context object. And this is sort of the magic. You have to sort of I had to sort of wrap my head around how async promises worked in JavaScript. Eventually, I think this is kind of beautiful, but the way it works is it starts by getting the context, it populates the form, it calculates the rating, and then it shows our buttons all in that order. And then I couldn't figure out a better way to do this, but I made this app context global variable, and I'm populating it from here. That's probably naughty, but it works, and it's the demo. And so this is kind of the moment we've been waiting for. This is what smart web messaging looks like. In this code snippet, we're finding the window object that we need to post messages to, and then we're sending it a message that says, "I'm done, close me." So this is all wrapped into a function called close app. So this is the action behind the red button, and also it's used by the update EHR button. You have to set the target origin, and I want to say that maybe we can get that from the client object. So I think this might actually be a bug. If you tried to hook this up to another sandbox, it might not work. So I'll fix that. And finally, this is the function that writes the data back into the EHR scratchpad. So here we've got the target window post message. We're inserting the payload, which is the updated draft order. And a good chunk of the logic is in applying what's in the form into that draft order. But then it's scratchpad.update. And I won't go into the code of, applying changes to the order. It's manipulating JSON and manipulating an HTML DOM. So as far as the roadmap goes for smart web messaging, it's kind of impossible to predict how the technology will spread. But I think with the PAMA imaging use case, it's likely to see action in 2020 and 2021. And along with this comes the need for better documentation and reference materials. And that's one of the reasons why I built the companion codelab the way I did. We really want people to start getting experience with this technology and providing us feedback. So there's a small and growing community. You can look for smart web messaging on the HL7 Confluence site. We have an early draft project scope statement, and we welcome interested parties to leave us comments. I expect that document to get fleshed out in the next few weeks. And as always, there are smart folks in Zulip in the smart stream talking about smart things. So I've left a generous amount of time for questions. Are there any first questions?
Where can I find the specification?
I don't have the URL memorized, but if you Google smart, or if you look up smart web messaging, you'll find it. I can look it up for you. Sorry about that. Any other questions? There's got to be at least one more. I have also included a list of the notable implementation caveats that I encountered along the way. So if you have access to the slide deck and you want to look at this later, this was sort of my confused moments, sometimes rabbit holes that took me a while to figure out. And, oh, Josh, I think I might have it here. No.
Yeah, that's a good one.
Oh, yeah. There you go. There it is. And finally, this is a glimpse of what the codelab looks like. This is how it's structured. Not all the details are fully there yet, but that'll happen soon. Yeah, thank you.